Hello friends and welcome to edupediaworld.com, your favorite destination to online education. Friends, as we have studied in last sessions about gas laws, in which we studied Boyle's law, Charles' law, Gay-Lussac law and the combined law which we call as gas equation. Friends, many students have come to me that they know the theory well, very well, but they are not able to solve the numerical problems. Why? Let's discuss in this session what are the tips to solve the numerical problem of a gas laws or any other law. Students basically face these kind of problem that they can't understand the question, they don't remember the expression of the respective law, even they don't know the conversions of unit, right? They don't understand the hidden values of the variable also. And moreover, they don't know the units. So are you facing these problems? So let's sit together and discuss about your problem. Now steps. I'll give you some steps. You use those steps and let me see that if you are able to solve the numericals or not. First step. Yes, it's a theory part. Let's see the theory. This is a law theory. This particular diagram, if you learn this diagram by heart, you will be able to solve much more easily the numerical problem, that you just have to see this triangle, make this triangle, keep three divisions, one pressure, volume and temperature. Above this you can keep the relations and the law's name. That is Boyle's law, Charles' law, pressure law. You can just mug up this particular diagram. Now second step is a formula or expression. Many students don't learn the formulas actually. You have to understand the formula or the expressions or the relation between the variables basically. That is the standard variable we are talking about, pressure, volume and temperature. Let's see this variable with the laws. Yes, these are the variables, equations which you have to learn, right? What is the Boyle's law with the relation pressure and volume? What is Charles' law? Volume and temperature. Gay-Lussac, pressure and temperature, and combined is this equation. You have to learn this formula for numerical problem. Let's go to the third point, that is units. Yes, units are very important in any numerical, whether it's chemistry, physics, or in any other mathematics. Conversions of units also. Now first let's see the units. We have volume, the standard variable, which have cubic centimeter cube, millimeter, cubic decimeter, liter. These are the volume units. We also have pressure units. One, that is atmosphere, ATM. Second, the height of the mercury column in centimeter is cm of Hg. In millimeter it's mm by Hg. In torr, third is a pascal. Third is a temperature. We have two units here in these laws, that is degree Celsius and Kelvin, that we call also absolute temperature, denoted by capital T. Now let's see the conversion paths. These basically are very important because the numerical gives the particular unit you have to convert into another unit. So the conversion, you should know the conversions of the units. For volume, you can see 1 meter cube is equal to 10 to the power 3 decimeter cube, or is also equal to 10 to the power 3 liters, right? In pressure, 1 atm is 76.0 centimeter of mercury column, is also equal to 760 of mercury column, is also equal to 760 torr. Second is 1 atm is equal to 101.325 kilopascal. Right, you have to learn these conversions. You the values, even though values are given in some questions, but still you have to understand and learn the conversion part also. And if you see the temperature, Kelvin is equal to Celsius plus 273. And you should note that standard temperature and pressure is 0 degrees Celsius is also 273 Kelvin, and 760 mm of Hg, that is mercury, is also it's equal to 76 centimeter of Hg or 1 atm. Now we have seen the conversions, we have seen the formula, the theory, the units. We have to learn all these things. Now let's come up to the steps how to solve the numericals. Yes, first and the very important, you have to understand and read the question carefully. Second, you have to pen down all the given values, and the constant values are also hidden values. Hidden values like some variable is tripled by the final value when the temperature or pressure is increased or decreased, kind of hidden values. You have to write the finding variable. Fourth, you have to write the formula used to find that variable. Now check all the units, if necessary do the conversions. Now please note that unit of pressure initial and final and volume of initial and final should be same. For example, if volume of initial has been given in liters and the final is into decicentimeter, you have to convert for the same, right? So then the calculation will be easy. And in temperature, these problems, numerical problem, will also be always be calculated in Kelvin part. If the question has Celsius or in any other, go with the conversions. Like if the question says into the 15 degree of Celsius is raised to find the temperature kind of question, you have to change first the Celsius part into Kelvin. Put the values in the formula and calculate carefully the decimal part. Resulted answers are just match the units, and if the required, again convert into units respectively. Now let's come up to the sample part. I have taken 3 random questions so that I can make you understand how to calculate the numerical problems of gas laws. First, I have the question like the volume of a given mass of a gas at 15 degrees Celsius is 100 centimeter cube. To what temperature should it be heated under the same pressure so that it would occupy a volume of 125 centimeter cube? Yes, you have seen here it's the same pressure, like pressure is constant. Now let's understand how to calculate this. I have given you the question. The question is the volume of a given mass of a gas at 15 degrees Celsius is 100 centimeter cube. Question say ask you to what temperature should be heated under the same pressure so that it would be occupying a volume of 125 degree centimeter cube. Now, first, have you read the question carefully? Right? Second, let's see the given part. What is the given part? We have 15 degrees of temperature, we have volume, initial volume, we have final volume, same temperature. We have to find the final temperature. So V is 100 centimeter cube. Initial temperature is 15. We have to convert it into Kelvin first, which will come out to be 288 Kelvin. V2 is 125 degree centimeter cube. Pressure remain constant, right? And we have to find the another T. So third, we have to write the formula. What will be the formula? What law will be? It will be Charles' law, right? Where pressure remains constant. So what is the formula? That is V1, V T1, T2, right? And fourth, by simple calculation, you can put the values in the formula like this. So what is the value you will get after calculating? That is 360 Kelvin. Now first you see the question is in the first temperature into Celsius part. So we have to convert the result T2, that is T2 360 Kelvin minus 273. So what the result is 87 degrees Celsius. So this is basically your result. I hope you have understand now. So let's take up the second part. Second question, which is bit of different. I've taken three random different questions. So what is the second question? At what centigrade temperature will be the volume of a gas at 0 degrees Celsius triple itself if the pressure remains constant? Here also we have the pressure constant. So let's see what the question says. The question says us at what centigrade temperature will volume of a gas at 0 degrees Celsius triple itself if the pressure remains constant, right? So again you have to take those steps. First, read question carefully. So here what we have given, the temperature and the volume is tripled of the first. The pressure remains constant. Let's write down. that is given part. What V is given? V1 is, for example, V1, and what is V2? V2 is triple of V1, right? What is first temperature? Is 0 degrees Celsius. We have to convert it into Kelvin. So 0 degree plus 273. We know the relation, that is conversion is this. Always keep the conversions in mind. That will be easy for you to calculate the numericals. So what is the T1? It is 273. Now we know that pressure is constant. So what the formula and the law will be applying to this question? That will be Charles' law. What is the formula? V1 upon T1 is equal to V2 upon T2. Just put the values. So I'm putting the values in this. That is V1 upon 273 equal to thrice of V1 T2. So what will be the value of T2? It's 819 Kelvin. Fifth, the question says at what centigrade temperature. So you have to again convert into centigrade part. So Kelvin minus 273 equal to centigrade. Put the values in this. So it comes out to be, so this is your final answer. I hope now you are going easy with the numericals. So let's take the third sample question. So third question says the pressure of a gas at STP is doubled and the temperature is raised to 546 Kelvin. What is the final volume of the gas? So here it is a definitely it's a question with the hidden values. So let's take the worksheet. So what the question says? Question says the pressure of a gas at STP is doubled and temperature is raised to 546 Kelvin. So what is the final volume of the gas? First, read the question carefully. Second, we have some hidden values in this. First, we have pressure and temperature in STP. That is, pressure is 760 mm of Hg and temperature is 273 degree Kelvin. So what is a P2? P2 is raised doubled, that is, that is and T2 is raised to 546, that is we have to add 273 to this much. Kelvin. Never forget to write the units afterwards, right? So what is a V1 is V1 and we have to find the V2. So what will be the formula we'll be using? Here you can say, see, everything is changing. Every third variable is changing. We have three variables, volume, pressure, and temperature. Three are different, having different values. So what will be the formula and what will be the law which we'll be using in this? This will be gas equation. What will be the equation? It will be P1 V1 upon T1 equal to P2 V2 upon T2. So let's put the values in it. By putting the values, 760 into V1 upon 273 equal to 2 into 270 to V2 upon 546. So by simple calculation you can find V2 this much. So what do you find? V2 is equal to V1. I hope you have understand now the steps and the problems which you can solve by these going with these steps. It will be very easy for you to understand and solve all the numericals, not only in this gas law. You can also solve by in physics and in chemistry, in mathematics also, but you have to just understand these steps and you have to learn all the formulas by understanding the theory. So let's come up the activity part. Now I hope you have understood all the steps and the sample questions which I have told you. It won't be problem anymore for you to solve all these questions. So what is the activity for you? Just take out your chemistry book and try out all the unsolved questions by these steps. I hope you'll be getting a right answers also. So now I'll be giving a full stop for this session and let's end up this session with the gas laws and the numericals. In next session I'll be starting with the new topic of atom and its structure, in which I'll be giving you introduction to the ancient atomic theories. Thank you friends. Thank you for attending this wonderful session.